Hey, this is Ryan Reuter at Oklahoma State University, and we're going to talk about nutrients and forage value. For grazing animals, this is going to be a little bit longer video, but we're going to talk about several topics, so let's get into it. First thing I want you to do is go back and review the video from a couple of days ago about the birds foraging and the different foraging strategies that we saw in these shorebirds. And remember that there were three birds that were kind of described in that video in pretty good detail. The reddish egret, the western sandpiper, and the long-billed curlew. And they had pretty dramatically different foraging types. And so go through and think about what kind of grazing animal would be similar to the foraging strategies of these birds. What similarities can you see with different types of grazing animals? And there's an assignment online on the Canvas system where you could write a short paragraph about some of those similarities and turn that in there. So if you would go ahead and check that out and complete that short writing assignment. Let's review really quick the stuff that we just finished talking about in the introduction. Excuse me, which was nutrient requirements of different animals, how they're different for different species. They change over the year, over the season, and that there's potentially different breeds and types and sizes and how all those things can affect nutrient requirements. Remember that we talked about these different types of animals and what they typically weigh, what their typical dry matter intake is. Hopefully you can recall what some of those typical numbers are. If you can't, stop the video, go back, review, and see if you can lock down on getting those dry matter intakes locked into your head. If you don't remember, here's kind of the summary, and remember that dry matter intake is related to body size, and we're going to come back to that issue here in just a minute. Talked about this figure showing the differences in nutrient requirements of sheep over the year. This same one with cattle, how their nutrient requirements change over the year. Hopefully you can remember what these different stages of nutrient requirements represent and the different stages of the year, the production cycle that coincides with these changes in nutrient requirements. And we talked about how different animals, different species have different digestibilities or produce different digestibilities of different nutrients in forages. So here's a really good exercise I like to go through. I like to help you start building some rules of thumb, or start putting in your mind some key numbers that you can remember when you get ready to start managing forages. And the requirements, nutrient requirements of these different types of animals, I think are pretty good to have as a stake in the ground for places and understanding how to manage forage. So what I'd like for you to do is you could pause the video and spend some time and fill this table out with the TDN requirement and the crude protein requirement of these different types of animals. And you could do this on a percentage basis, percentage of dry matter basis for TDN and crude protein. I've given you a couple of links here that you could follow in the slides to find some of these numbers. But you're going to look for three different kinds of cattle and what their nutrient requirements are. I've gotten you started here with a steer gaining 2 pounds a day. That animal typically has a nutrient requirement, a TDN requirement of about 60% and a protein requirement of 10%. And I'd like for you to fill out this table for the rest of these kinds of animals for that. So pause the video and go look up a lot of those nutrient requirements. There's places on the internet, and I've given you links here to a few to get you started on that. Okay, so let's talk about a few critical nutrients, and this should be a review for everybody that's had applied animal nutrition one of the main nutrients that animals require is energy. And energy can be measured as digestible energy, or TDN, which stands for total digestible nutrients. It can be expressed as metabolizable energy or as net energy. And the system that we use to express the different types of energy kind of depends on the species, and it depends on the person the system that they prefer to use for a specific scenario that we're in. So digestible energy is commonly used for horses. It's commonly also used for small ruminants in many cases. The TDN system was often used for cattle in the past, and in some cases, especially in forage situations, TDN is still pretty useful for cattle. Metabolizable energy, I think swine base their requirements off of metabolizable energy, and then in modern times, the modern cattle nutrient requirements are expressed in terms of net energy. So in forages, the energy value of a feed or of a forage is largely a function of the digestibility of the fiber in that forage. Okay, so there's kind of two sides to each of these nutrient issues. One is, what does the animal require, and the other is, what does the feed supply. And so in forages, they supply energy largely through digestibility of the fiber. And just to review some plant physiology, this is kind of what a cartoon of a plant cell looks like. You get lots of cells packed together to make up plant tissue. The cell contents are pretty soluble and pretty highly nutritious. They include things like proteins, sugars, a few fats, starch, pectins, those kind of things in the cell contents. And then most of your fiber or cellulose is in the cell walls, and you can kind of see how they've got plant cells have a primary wall and a secondary wall, and where a lot of those cellulitic and fiber compounds, cellulose type compounds, are found in those plant cells. Cellulose is the majority of these compounds. And so this is kind of another illustration of that. You can kind of see how here's a chain, a polymer of cellulose that shows you what that looks like, how hemicellulose is bonded a little different. Here's pectin, but those are the carbohydrates that supply the majority of energy from forages. So something real important to understand as a concept is that forage quality changes as the maturity of the plant changes. Okay, and if you start with a young plant that's immature, it's generally high in protein, energy, vitamins, minerals. Okay, and it's going to be low in fiber and lignin. The concentrations of those nutrients are going to play out like that as a plant is immature. And then as any plant matures, it tends to accumulate fiber and lignin, so the concentration of fiber and lignin is going to increase, and the concentration of protein, energy, vitamins, minerals, those things are going to decrease as the plant matures. And then as the plant gets very mature and even goes dormant, or is dormant and rained on, and nutrients are leached out of it, then the concentration of those soluble nutrients, protein, energy, vitamins, minerals, get very low, and the plant is essentially the vast majority of what that material is left is fiber and lignin in those plants. And so that this applies to all forages that we graze, and it's real important to understand that concept about maturity affecting forage quality. It even happens in really highly nutritious forages like wheat pasture. You can see here at the beginning of the grazing season in wheat pasture here in Stillwater was about 30% crude protein on a dry matter basis, and it stayed pretty high in protein until the plant started to mature. And this time period right in here, about 120 days on pasture, is when wheat makes the transition from being vegetative growth to reproductive growth and starts trying to make a grain crop. And so that's a signal of maturity in those wheat plants, and you can see the protein content of those wheat plants start to tail off even when that plant gets more mature. And so even in a forage as high quality as wheat, maturity definitely affects the nutrient content of those plants. Here's the same thing with the effect of maturity on coastal Bermuda grass. And you can see it's even more dramatic than what we see in wheat, with grass that's 4 weeks old is very high in digestibility and protein. In this case, in the low 60s in digestibility, and 16 or 17% crude protein at 4 weeks of age. And then, as you see, as we even get 2 weeks later, 2 weeks older, the protein content has dramatically decreased down to 11 or 12% protein. Digestibility is decreasing too. And then you add 2 more weeks to get to 8 weeks of age on that forage, and it's just moderate quality at best in that case. So pretty dramatic effect of maturity on quality of Bermuda grass. An important concept to understand, I think, is to think about the hierarchy of forage value. And we talked about cool season and warm season grasses in a previous discussion, and there's a link here. You could go read a little bit more about carbon metabolism in grasses to understand the effects there. But in general, as far as forage quality or forage value, forage nutritive value, it's important to remember that in general, cool season grasses or C3 grasses have greater nutritive value than warm season grasses, all else equal. Okay. The same thing is true with legumes. Legumes in general have greater nutritive value than grasses, assuming that the maturity is the same, management would be similar, that kind of thing. Okay, the same is true, the same relationship holds with annual plants versus perennial plants. So plants that have an annual growth pattern, that are annuals, generally have greater nutritive value than animals with a perennial growth habit. Here's some data that kind of illustrates that point. In the top panel here are grasses, and these dark bars are grasses from tropical regions. These are almost all C4 grasses, and then the lighter shaded bars are from temperate regions. These would be more C3 grasses, and you can see the distribution of digestibility, and you've really got 2 different populations here. Those C3 cool season grasses have greater digestibility than the C4 warm season grasses from the tropical regions, and a pretty dramatic difference in this database. The bottom panel is legumes from tropical and temperate regions. Same thing. You don't see as big a difference in legumes, but there definitely is a tendency for C3 legumes to have greater nutritive value, greater digestibility here than C4 legumes. Not as dramatic as in grasses, but still that relationship is still there. So I think it's interesting and good to have to think about ranking some of these different types of forages. And if you wanted to do that, we could put cool season annuals, and let's just talk about grasses for right now. I think that kind of simplifies this concept. But in grasses, if you could put cool season annual grasses at the top of the ranking for forage nutritive value. Okay, and then underneath those, the next tier down would be cool season perennial grasses. Okay, the next tier down would be warm season annual grasses. And then finally, warm season perennial grasses tend to be have the lowest nutritive value of any of these forages. And so that relationship and that hierarchy is something worth remembering. I'm going to illustrate why I think that's important here in just a second. Here are some examples of these different types of forages. Cool season annuals, we've already talked about wheat pasture quite a bit, but that definitely is a cool season annual and is very high quality. Oats, ryegrass, those kind of forages are basically as good as wheat pasture and are at the top of the hierarchy in terms of forage value. Underneath them are cool season perennials such as fescue, wheatgrass, timothy, those kind of forages. There are many others that are generally pretty high quality forages. Underneath those are warm season annuals such as Sudan grass, Corn, actually, is a warm season annual grass. Crabgrass is another one that makes pretty good quality forage. And so, but those warm season annuals are generally not as as nutritious as cool season plants that are ranked above them. And then at the bottom of the list are warm season perennials such as Bermuda grass, yellow blue stem, tall grass native range, and obviously there are many other warm season perennials, but those warm season perennials tend to rank at the bottom. Okay, so if you filled out your table on what you think the nutritive value of these different types of animals are, I think that table is going to be really useful here in a minute, especially thinking about these different types of forages. And so this is what I came up with that I think is a pretty good estimate of the differences in the requirements of these different types of animals. And so let's pick out a couple to talk about. Let's look at that steer that was gaining 2 pounds a day. I've updated the requirements here. I hope that you probably may have realized that those ones that I showed you before were maybe a little low, and so I think these are a little bit more realistic. 68% requirement for the steer gaining 2 pounds a day in terms of TDN, 68% TDN, 12% crude protein for a steer like that. This steer may weigh 450 or 500 pounds or something like that. Okay, so he's got pretty high nutrient requirements, okay, relative to the other animals in this table. The animal with the lowest nutrient requirements in this table is probably this mature dry cow, and her requirements are about 50% TDN and only about 7% crude protein. Okay, so you could kind of rank these different kind of animals in their relative nutrient requirements. Okay, so now let's put this concept together of animal requirements and forage value, and we'll go through that same hierarchy of forages. We've got cool season annuals at the top, and they're the highest in nutritive value, and so they fit and are probably best utilized by animals that have the highest ranking for nutrient requirements. Okay, so you're matching supply and requirement here. So if you've got cool season annuals, you want to think about trying to utilize those forages with stocker cattle or with dairy cows or animals like that that have a really high requirement for nutrients that these cool season annuals can supply. Okay, that's going to be the most efficient, probably most economical use of cool season annuals. If we were to think about cool season perennials, we could definitely use those with stocker cattle. They may gain a little bit less, but we could use those with stocker cattle. Or lactating beef cows are a good match for the nutrient supply capability of a lot of cool season perennial grasses. If we go down to warm season annual grasses, we could definitely use those with stocker cattle. Again, they're going to gain a little less, but they can use them. But beef cows are a great way to use warm season annuals. Many of our warm season annual grasses pretty easily supply the nutrient requirements of a beef cow for most of the year. And then down here at warm season perennials, those are best utilized by beef cows with low nutrient requirements, especially beef cows that are dry, that are not lactating, are going to be able to make good use of warm season perennials with minimal supplementation. And so that's a good use of those kind of forages. We can still use stocker cattle to utilize warm season perennials, but the seasonality is going to be important. So remember back to the maturity thing about the forages. If we're going to use stockers on warm season perennials, we want to use those early in the growing season when those grasses are relatively immature. Okay, and so this table illustrates a real important concept of matching forage production and forage quality with the nutrient requirements and the type of animal that you're trying to feed. If you get these things mismanaged or mismatched, you're going to run into some real problems. As an example, I always use, let's say you had a grazing dairy and you were trying to produce fairly high production dairy cows on forages, and the only forage that you had available was warm season perennial grasses. Well, you've got a real mismatch in the forage supply and nutrient demand. And so you're going to have to spend a lot of money on supplementation to try to make that system work. It's probably not going to work from an economic profitability standpoint. So those are the kind of the issues that you want to think about matching forages to the animals that you're trying to feed with it. Let's switch gears here just a little bit and talk about intake for a while. Intake is really important to understand when you're thinking about how to manage some of these forages. Something that's real important that I always try to remember is that if you're looking for performance in animals, whether that's milk production or gain or rebreeding performance in cows, but intake drives performance. If you can get animals to eat more forage, they're going to consume more nutrients, and those nutrients will be available to them. If you've got some kind of a situation where you limit intake, then in many cases the nutrient content of the forage starts to become irrelevant because cattle can't eat enough of the forage to get the nutrients that they need. So intake is critical to managing performance and being efficient in cattle. Okay, so it's worth repeating that intake drives performance. And then another thing to think about intake, it's really complicated. Okay, just like nutrient requirements have a lot of factors that go into it, intake has a lot of factors that affect intake. So digestibility of the forage affects intake. Nutrient balance and availability in the forage affects intake. We'll get into some of those issues a little in future videos and future discussions. There are physical factors about the forages that can affect intake. Animal type and physiology definitely affects intake. Behavior, weather, and the list kind of keeps going about what can affect intake. So show you this quick video here of a steer just out grazing some cool season pasture, and this might look like a pretty simple and pretty calm event of just watching this animal graze, and it definitely is kind of relaxing to watch it. But what's important to realize is there are a ton of factors at play here, going into how this animal grazes and how much it grazes, how much of this forage it can consume in a day to meet its nutrient requirements, and so all those things are super important. And while that's a pretty common thing to see, cattle grazing, it's one of the most important things we can try to manage as grazing managers is intake. So here's some figures just trying to illustrate what the effects of some intake are. These were cattle that were actually in confinement, but the principle holds true for grazing animals. You can see here a direct relationship between feed intake and average daily gain. So this is where we're going back to saying intake drives performance. If you want cattle to gain well and gain a lot of weight, you have to get them to eat quite a bit of feed. So that's a real important part of management. So, kind of similar, you could ignore the two different lines here. They're from different, comparing a couple publications about intake, but you can also see feed efficiency is much improved if you get animals to consume more feed. And so again, this shows how intake is real important for gain and performance, but also for efficiency. So let's talk a little bit about how some of those factors may affect intake. And we talked previously about weight, how it affects intake, and I want to show you something about that. So we've got a chart here that's got some dots on it, some data points on it, and these kind of showing you the relationship between body weight and intake. Okay, so we've got a body weight here of cattle ranging from 400 to 800 pounds. So these would kind of be typical stocker cattle, and we've got an intake here from say 7 or 8 pounds up to maybe 18 pounds of forage. Okay, so we kind of got that relationship, and obviously the first thing that you notice is that there's a pretty strong relationship between these two, and this blue line is the regression line that models the relationship between weight and intake, and you can see that as weight increases, intake increases. Okay, so let's look here at about 450 pounds, and let's look at a hypothetical animal that weighed about 450 pounds. We would expect from this data for that kind of an animal to eat about 10 pounds of forage. Okay, so if that animal eats 10 pounds of forage and weighs 450 pounds, how much is that in terms of a percentage of that animal's body weight? So basically take 10 and divide by 450 and see what that percentage is. Go ahead and pause the video and do that. And so if you did that math, you'll see that 10 divided by 450 is about 2.2% of that animal's body weight. And so you can see here that would be our estimate of intake at 450 pounds would be 2.2% of the animal's body weight. Let's go up here to another animal, a hypothetical animal at 750 pounds. We go up and look at the regression, what we expect here. That animal we expect would probably eat about 17 pounds of forage. Okay, and so if you take 17 divided by 750, that's also 2.2% of body weight. Okay, so it's interesting to note that intake, a good way to predict intake in grazing animals is to understand their weight. And heavier animals are going to eat more forage, and they eat more forage in proportion to their body weight. So a number of 2% of their body weight, or 2.2, 2.5% of their body weight is a really good way to get a rough estimate of what you think the intake of an animal should be. Okay. Now, what's interesting to note here is that that regression line goes through there and does a really good job of estimating intake, but all these data points aren't directly on that line. There still is some variability, right? Like this animal ate more than what we expected based on its body weight. This animal over here ate less than what we expected from just its body weight. So there's obviously still some things going on here that affect intake besides just body weight. And those factors are some of those things we mentioned before: the digestibility of the forage, the nutrient balance of the forage, differences between animals, animal behavior, some of the things about animal physiology that's going on, maybe breed type. Those kind of things can all affect intake. And that's what you're seeing here in these deviations from the regression line. These are the differences due to those other factors. But what you kind of notice is that the differences due to these other factors are really pretty small compared to the effect of body weight. Okay, so that's why body size is such a great place to start in being able to predict intake, because it explains most of the variation in intake. Those other factors explain quite a bit less of the variation. Here's some of the other things that you could see that start explaining some of that other bit of variation. This top panel here is the relationship of diet digestibility to dry matter intake in growing calves. So these would be in stocker calves, and you can see here a TDN value of 54, which would kind of be a moderate quality forage, up to a value of 75 or 80, which these would be concentrate based diets. Okay, so our forage diets are kind of going to top out around here about 65 or high in the high 60s in terms of TDN. So this part of this graph is about where we see forages land. And what you can see is that in 600-pound calves down here, if you got moderate quality forage, they're going to be down there at about 2.2% of their body weight in dry matter intake, which is about what we predicted from the previous graph. We kind of illustrated that. But as you increase the digestibility of the forage, those cattle tend to eat more. The forage is more palatable, it's more digestible, it clears out of their digestive system faster and makes more room, allows room for them to eat more, and so they do eat a little more. So at up to 65% of TDN in those kind of forages, 600-pound cattle might be expected to eat 2.4% of their body weight instead of 2.2. Okay, so you can see how we adjust our estimates of intake based on some of those other factors besides just body weight. So And then you can see here an example of a 300-pound calf. You see that same relationship with digestibility happen, but you also notice that those smaller cattle tend to eat a larger percentage of their body weight than heavier cattle do. The small cattle, just that is kind of a function of the math of how they work. So small cattle tend to eat a little greater proportion of their body weight. Down here in this bottom panel, there's the same relationship with cows, and these are these ranges of TDN are real common, kind of where just our forage typically is in TDN. Down here in the low 40s, this would be a really poor quality forage, like dormant native range that had been rained on or leached or something like that would be down in this area of the graph. And then up here at the high end, in the high 60s, would be something like wheat pasture or something like that, or high quality fescue or some kind of forage in that neighborhood. And as you can see, cows, as you increase digestibility of the forage, you see the same relationship, that intake increases as digestibility increases. And so if you start way down here at super low quality forage, you're going to have cows that only eat 1.5% of their body weight in dry matter. Okay, but if you get up pretty high quality forage, you can see cows that eat 2.3% of their body weight in dry matter per day. And so, that body weight is the best, explains the most of the variation in intake, but then digestibility can also explain some of these deviations as well. Okay, and that's kind of what you're seeing here. So we're kind of building up how many factors that we're thinking about when we're trying to understand the intake of grazing animals. Okay, there are a couple other ways to estimate intake of cows, and here's a nifty little formula if you want to try to remember this one, and it kind of combines the body weight thing that we talk about here and this digestibility effect that you see here. Those are two of the big ones that affect intake, and this little formula kind of combines those. And so if you'll notice, or you can kind of make a note here, that cows eat about 1.2% of their body weight of NDF. Okay, NDF's neutral detergent fiber. If you're not familiar with that, click on this link and go read about NDF. But it's a component of the fiber fraction of forages. But cows eat about 1.2% of their body weight of NDF every day. Okay. And so if you look at a 1,000-pound cow and you multiply it by 1.2%, that says that she'll eat about 12 pounds of NDF. Okay? And so now that you know that this cow is going to eat about 12 pounds of NDF, if you know how much neutral detergent fiber or NDF is in the forage that you're consuming, it's real easy to estimate intake. Okay? So she's going to eat 12 pounds of NDF, and that if she's eating summer Bermuda grass, we think that a good estimate for that kind of forage is that it's about 57% NDF. So if you take 12 pounds of NDF, divide by 57%, we'd estimate that 1,000-pound cow would eat about 21 pounds of summer Bermuda grass dry matter. Okay. Now this cow is going to eat about 12 pounds of NDF every day, but if we're trying to graze her on dormant native range, that might be 78% NDF, which means it's got more fiber in it, it's less digestible. Okay, we can still use this formula to estimate intake. 12 pounds of NDF divided by 78% NDF gives us an estimate of 15.5 pounds of dry matter per day for that cow. So on dormant native range, we estimate she would eat substantially less dry matter than on summer Bermuda grass. And that makes sense because dormant native range is much less digestible. It's much higher in fiber. It's slower digested, and so cows can't eat as much of that forage, and that's what this little calculation shows you. So that's a real handy way to and a good tool to have in your toolbox for managing forages and predicting intake of cows on different kinds of forages. If you want to go read some more, there's an interesting paper here where some Australian researchers estimated intake of stocker cattle using just the weight of the stocker cattle and the average daily gain that they observed from those cattle. And so they were using average daily gain as a proxy for forage quality, and we're able to estimate intake using just those variables. If you're interested in that, go read that paper. It's a pretty cool approach. So that brings us to another little table, another rule of thumb that I think is real important to understand for forage management. And this is intake rules of thumb for cattle. And so for my default, I recommend using, if you don't know anything about the type of cattle or the type of forage, the default intake for cattle is about 2% of body weight. And so if somebody asks me what do cattle typically eat, I'll say, well, they eat about 2% of their body weight, but then that depends on several factors. But if I have to have a default, it's about 2% of body weight. If we're on really low digestible forage, I'm going to reduce that down to about 1.6% of their body weight. Okay. If we've got good quality forage, I'm going to bump it up to about 2.3% of their body weight. If we've got stocker cattle, younger cattle on high quality, abundant forage, like really good wheat pasture, we could bump that up to 2.8, maybe even 3% of their body weight. Okay, but typically intake of cows is going to stay kind of in this range as a percent of body weight across a lot of different forage scenarios. So this table is really good to have in your back pocket. Here's a fact sheet that's linked here that talks quite a bit about interpreting forage and feed analysis reports. So if you take samples of forages or samples of hay and send them to a lab and get them analyzed, you're going to get a report back about the chemical composition of those forages. And this fact sheet will walk you through how to interpret those and how you can use some of those analysis reports to help you estimate intake and other kinds of things that you'll need when you're managing forages. And so as a practice, at the end of that fact sheet from the previous slide, there are 2 forage analysis reports at the end of that fact sheet. And so for you to practice on, I would like for you to take those 2 forage analysis reports and estimate the dry matter intake and the as-fed intake for the following animals for each of those forages. Okay, and so I've given you some example animals here. Let's go with an 1,150 pound gestating cow, a 600 pound replacement heifer, a 1,325 pound lactating cow, and 125 pound gestating ewe. Okay, so take those 4 animals and those 2 forages that are in that fact sheet and estimate intake both on a dry matter basis and on an as-fed basis for each of those forages, and bring that to class, and we'll go over that in lab and answer questions and talk about what the differences are between those different types of forages and different types of animals. But doing this little practice will give you some good information about and good practice on using feed analysis reports to help you manage grazing. And that's what I had to share with you this time. Appreciate your attention, and we'll be back with you in the near future. Thanks.